Okay, so yesterday we familiarized with the requirements for the evacuation, and we talk about the ratings of airplane exit doors, emergency exit doors, that are determined by the CS and FAR regulations. And here you could see the number of such ratings for each pair of the doors. Okay, so here we could discuss some example of realizing of such approaches, and there are requirements, and there is some exception from these requirements. And here, as example, you could see some airplane with not symmetry in the different type of aircraft exit doors allocation. So we have from left side type 1, then double type 3 in the mid part of airplane, and type 1 in the aft part of the airplane. So, and when we talk about type 1, it's a 45 passenger per exit, and type 3 is 35. If we talk about the double type 3 with a number of rows less than 3 between these types, so it will be 70. For this example, we have a significant so-called dead ends. In case of this emergency exit failure, we haven't possibility to evacuate this crowd of passenger uh, from this type 3 doors. So that's why and in case of this and this type exit door failure, only this type 3 door will be a possible way for emergency evacuation. So according to that, we will use a capacity of 70 passengers for this airplane. So the appearance of this door will not influence on the aggression possibilities of airplane, because it will be, in case of failure, a dead end for this part of airplane. So it's a not good combination of emergency exit. The other one, similar to previous one that we discussed yesterday, it was a combination of type 1 and type 3 exit doors. And you could see it will be in next combination, type 1, type 3 from left side, and type 3 and type 1 from other side. So according to that, 35 for type 3 exit, and 45 is for type 1. So according to the combination of this door, it is possible, but you need to prove through the demonstration to increase a rate of evacuation from 70 35 for this type 3 and 45 for type 1. So you could increase it up to the 79, not 80 like assume of these two types of the doors, but to 79. And what is the reason of such approach? We could say that typically during the emergency landing, we have a problem from one side of airplane due to the roll or due to the spillage of the fuel. So that's why it is possible to say that type 3 will be in combination with type 1 exit door. But as it will be a limitation, so we could not use 80, it will be like only 79, less than the sum of these two types of the door. But this demonstration This proving must be approved by the demonstration of the evacuation test. So, when we talk about number of passengers on the board, how we will calculate them? Flight attendants that are present in the cabin will be not part of the total passenger on the board. So that's why the flight attendant seats will be not taken in account. Only passengers. We'll calculate them separately. And when we will determine the maximum capacity of the passenger in so-called type data sheet, it's additional document for the type certificate, we need to take for consideration uh, other parameters. First of all, they're connected with limitations and could be determined through the requirements for ratings of the door. First of all, from this table, we will determine the requirements or limitations. And it could be also taken in account some factors that will formalize in next slides when we will discuss the possibility to provide evacuation according to the redistribution of the seats on the board, because it could be a part of fuselage with a high density as an economy class, and low density part with business or first class part of transport cabin. But as you know, the doors are applied for the structure. You couldn't change them if you will reconfigure your layout of an airplane. So already existing doors must be taken in account. So it will be a significant um, restriction. And next one is a ditching exit. What is the problem of ditching exit? Ditching, it's mean a landing on the water of a plane, and some of the exit due to the center of gravity position could be under the water line. So you couldn't open them, you couldn't use them uh, in the normal, not normal, I mean incident landing on the land, but in the water you couldn't use them. So that's why it will be additional limitation. So under waterline door will be a restriction for the determination of total number of the passengers on the board. And mm, as example, on Antonov 148, it is T-tail airplane. So it is an airplane with a significant weight of the empennage due to the specific of the structure of empennage, and I try to make a sketch. So not good, but it will be just in a sketch. So after part, after emergency exit, will be a little bit lower than waterline. So a decision for this case was to use some barrier that must be installed uh, in the bottom part of the open hole of emergency exit, and it will be emergency exit hole. So if it will be landing on the water, the flight attendant must put some special barrier in the bottom part of this hole to avoid water incoming in the passenger cell. So by means of this technical decision, we could use this emergency exit. So we prove a ditching exit for ditching condition. On some airplanes, as example, it could be emergency exit that has two separate parts. One, the door could be opened totally on the land, and only the upper part if it will be ditching on the water. And it's a other example of the ditching door approving solution. So according to that, we have some limitation, and we must take them in account for the determination of the number of the passengers or the boards that could go through the any exits. Okay, so next one. Each emergency exit in the passenger compartment must be determined to the minimum number of required emergency exits with the limitations, and any floor level door or exit and larger than type 2 exit must be not less than 1.17 meters wide. And when we talk about these parameters, they are described in the type certificate or supplemental type certificate. So it's a document that describe the requirements for the airplane. And these evacuation procedures and the number of the passengers that could be evacuated from all these exits are described in the type certificate and determined by the developer. So additional requirements for the ditching emergency procedures. So if we have an airplane with a passenger seat configuration of 9 seats or less, it must be one exit above the waterline, and its dimensions must be a type 4 exit. It is 9 passenger per this exit. For airplane that has 10 and or more passenger, it should be one exit above the waterline. And then, according to the number of the passengers on the board, it will be type 3 exit, and it will realize 35 passengers evacuation. And also you could increase this type 3 exit. It will be a mid version between type 3 and type 2 to increase the ratio for the evacuation. And if we have side exits that are under the water, you could replace them by the overhead hatches. So as example, you have two type 3 exit from left and right side, and all of them will be not proved for the ditching. So that's why you could use a hatch that allows to evacuate 35 passengers through it as a type 3 door. But it will be enough only one, because for sure it will be under free access, because it is located in the mid of the airplane. So that's why you could use an overhead hatches, and sometimes you could find them in small airplanes up to the 35 passengers on the board, as example of such approach realizer. For crew compartment, for crew members, we if we talk about especially about the flight deck, they must be this compartment equipped with their own emergency exit. It could be hatches or windows, slide windows, with the dimensions that equal to the 48 up to the 50.8 centimeters. And in some airplanes it will be overhead hatch, or it will be just in a slide window. But for sure, it must be an element for the evacuation if your number of passengers will be greater than 20. Because, as you remember, we will separate our flight deck from the passenger compartment by means of uh, flight deck door for safety. So, to summarize all knowledge about the types of the door that could be applied on the airplane, this is based on these descriptions from paragraph 25.87. So, for number of passengers less than 179, you could see how many emergency exits must be. For a passenger number from 1 to 9, it will be enough type 4 emergency exit. But in many examples, you could find that it will be more than type 4 emergency exit, because it will be one door for the passenger incoming. So that's why it will be, from the point of view of comfort, more than type 4 emergency exit. And then from 10 to 90, type 3, and then you could see from 20 to 39 it will be increased, and you will use two type of the doors. Then for maximum 179, for sure it must be type 2, type 1 emergency exit, and double type 3, like on Airbus 320 or Boeing 737, where we have double type 3 emergency exit over the wing. But for Airbus 340 there are 180 passengers on the board, so it will be one extra passenger on the board, but they still use this approach. Why? They approved it by means of demonstration of test, and also they type 1, it will be oversized type 1. It will be bigger than type 1 emergency exit. So they said that they could use this requirement type 1 in forward and aft part of the fuselage, and the type 3 in the mid fuselage for 180 passengers, due to the increasing of the type 1 size door. So if you have more than 179 passengers on the board, but less than 299 passengers, so you will add additional doors, and it will be one from this type, or maybe for 299 it could be a combination of such doors. So again, we have a standard approach for the determination of the type of the door on the board. We will add to this combination extra door from this list up to the 299 passengers. But if it will be more than 299 passengers, there are only type A or type 1 emergency exit on the board. So you will use only this combination, type A and type 1, without type 2, type 3 or other doors. And if you look on the huge airplanes like Airbus 330, Boeing 767 and so on, you could see that they use only type A or type 1 emergency exit. Okay, let's summarize our knowledges. Maybe do you have questions? We could discuss them because it will be an other part for the determination of the redistribution of the doors. So do you have questions about the ratings of the doors? So this number of passengers of the doors is a rating of the door.
This doors is only emergency doors. What about entry doors?
So any doors on airplane in modern airplane will be also an emergency doors. So enter door or exit door will be also emergency exit.
Okay, okay.
So the purpose of this slide to recall this information. We have some special combination of the doors that must be used on airplane. They proved you could use other combination, but it will be difficult to certify it. You must prove it well. Why you change this combination? For example, you could use type double type 2 doors and double type 3 as example, but no, it's not good. Maybe in this combination, double type 2 and double type 3 door for maximum number of the passengers on the board, but it will be difficult to prove the reason of these doors. But through the demonstration, you could maybe approve this combination. The typical solution is shown here, but maybe these standards will be reviewed in next years due to some problems with the evacuation that happens during the emergency situations on some airplanes and especially in the accident of Sukhoi Superjet 100 in Moscow airport a few years ago. Next one. Now we will discuss procedures for the determination of redistribution of the passenger exit. And here we will use next approach and next definition. We use term passenger zone. So passenger zone will be determined by means of the pair of exits from forward up to the aft part of the exit in this zone. So it will be a passenger zones from exit to exit. But in some cases, if we talk about the dead end, when there are no emergency exit in the forward part, let's imagine that flight deck will be located here. So we have an emergency exit in forward part, so it will be a dead zone. So in this case, passenger zone will be from the most forward seat in our row in this part of the cabin up to the emergency exit. But it must be more than 4 seats in this zone. In our case, directly 4. It's not a good example, but let's imagine that there are additional row. So it will be additional zones that must be taken in account. Exit rating. It's a number of the seats of passengers that could be evacuated from the different type of exits. The maximum one The maximum one is type A. And maximum seating configuration. It's a maximum allowable number of passengers on the board that could be applied for your airplane, but not a type airplane, but not directly for your airplane due to the configuration of operator layout. Because from operator to operator, different layouts, different seat pitch, a different combination of business and economy class could influence it on this capacity. Passenger cabin length. Again, it will be determined from the most forward up to the most aft emergency uh, exit, and or up to the seat most aft or most forward seat in your cabin. And if you have tail cone or ventral exit, so there will be also a boundary for your passenger cabin length. So if you have a tail cone exit, so your passenger zone length will be determined up to this tail exit, like MD-80. You could check this airplane with tail cone exit. Exit unit. So please pay attention on this element that we will take in account in our calculation. So exit unit is first of all dimensionless number, and you will determine by the dividing type rating on the type 3 rating. So type 3 rating is 35. So if we use exit unit, if we want to determine exit unit for type 2, you must 40 divided on 35, and it will be 1.14, and we will round down it, and using the next principle, we will round down it to nearest quarter of the unit. So what is a quarter of the units? It will be 0.25, then it will be 0.5, 0.75. Example, here we have for type 1 1.28. So we will round down it to the nearest quarter. It is 0.25. So it will be exit unit 1.25. For type A, here it will be 3.14, and we will round down it to 3.0. What else? This it will be the typical rounding of the units. Next one, fuselage length factor. So it's a length determined by the dividing the length of the passenger cabin by the sum of the exit units. So we'll determine the sum of these exit units that are rounded down by the nearest quarter. Exit offset. It is possible that it will be some shifting from the determined position, original shifting of the emergency exit from the calculated value. For example, from the calculations, the center of the door must be located here, but in your A-plane, the door will be located in this fuselage station, and it will be exit offset. It must be in the boundary of 15%. Then individual zone passenger capacity. We talk about the passenger capacity for this part of cabin, and it will be determined by the pair of exit in aft and uh, upper forward part of fuselage. And sequential zone passenger capacity. It's a combination of two zones of this zone and let's let's imagine that it will be additional zone that is located here with passenger, for example 50 passengers in this part. So we also determine a sum of this nearest zone. Okay, so to do not waste the time, I pay attention on next one. So how will determine a 75% capacity for the dead end? It was taken from the A-plane operator that has a combi version. So a half of A-plane is a cargo A-plane, the aft part is a passenger A-plane. And it was determined that from the analysis, from the experience, that this exit must be derated on quarter. So 75% could be evacuated from this door if it will be an limitations in forward part. So you could see only one exit door pair possible in this cross section. So that's why we decrease it on 25%. What about reconfigurations and the necessity of appearance of additional doors? As example, on Boeing 737 MAX 200, it's a special configuration of 737-800 for if we talk about the layout for Ryanair Airlines. And they ask Boeing to increase from the maximum capacity of 189 passengers up to the 197 passengers. And the result of this increasing was additional emergency exit door appearance in A-plane. So we could see that increasing only in 8 passengers lead to the significant reconfiguration and modification of A-plane, just to give opportunity to provide the same necessary level of evacuation rate. And if you look carefully on 737-900, A-planes is the largest version of A-plane. You could notice that some of A-planes has uh, aft the wing emergency exit, but few of these A-planes will be marked with emergency exit strip line. Some of them will be not marked. What does it mean? It means that a configuration of A-plane aircraft layout will be different. In this case, it will be business class or first class presence that will decrease the density of passengers on the board. And this one, it will be airplane with high capacity passengers on the board. So it means that we need to use this emergency exit. And in configuration of this airplane, you could see additional emergency passageway to this door, and door could be activated during the evacuation. In this airplane, inside the cabin, you will not see any signs of emergency exit. It will be covered by the interior panel. Okay, so again, let's look on this table that will summarize different requirements. So, if we want to determine the number and location of the passengers through the passenger cabin, we said that evacuation flow will go through the nearest exit. What does it mean from the point of view of passenger? So, this passenger will go through the nearest exit. It is possible to imagine that some of the passengers will go to the forward one to try to evacuate, but consideration in our regulations will be next. All passengers will be evacuated through the nearest emergency exits. So that's why it could not be a crowd from the passengers from this side of cabin in this part of passenger cabin. It's a decision that was taken into account by the government. Next one, the passenger capacity of the passenger zone is limited by the sum of the ratings of the exit. So type rating of this door plus type rating of this door will be a limitation for this compartment. If it will be type 1, it will be type double type 3, so assume of this 70 plus 45 will be limitation for this emergency exit. Next one, if we talk about dead end, and dead end means if you have more than 4 seat rows in the passenger cabin, so it will be dead end, and your rating must be reduced on 25% up to the 75%. And location of the proximity of exit. The rating of the exits could be shifted on plus minus 15%. And what else? Double type 3 exit doors could not be located in the forward and aft part of the fuselage, only in the mid part. If you have more than 3 seats between the exit type 3, it will be determined as 65 passenger per as this double type 3 exit. But it will be 5, 6 seats, not more, because if it will be more than this number, it will be better to calculate it separately. But if we talk about double type 3 exit door, and as you remember, it must be over wing door. So dimensions of the wing will not give us opportunity to put more than 4 or 5 exits. 4, I guess it will be the maximum, or 5 it will be the maximum. So in this case, it could be only 65 passengers, but typically it will be located in the distance 1 or 2 seats between there. So double type give us 70 pax. And how we will divide this zone? Where is the boundary of the zone? It must be a center line of the exit, but if we talk about double type 3 door, it will be the mid center line between these doors. How we will calculate these passenger seats? It will be passengers of the forward part, or it will be passengers of the aft part of the cabin. So to determine the address, we will use a fitting of the seat, forward fitting of the seat. If it will be from the left, from mid line, so these passengers are the forward compartment passengers. Next, a consideration for the analysis: maximum seat configuration. We need to determine for individual zone passenger capacity, and also you will determine secondary zone passenger capacity from nose to tail and from tail to nose, and maximum passenger seat configuration. Then you will determine exit unit, divided them on 35 type rating of type 3 door, fuselage length factor, and nominal exit location. So, and the length will be used by the fuselage stations that are determined in the aircraft designer documents. Let's discuss these all approaches in the example of calculation. We have a plane that has type 1, then type A emergency exit, type A emergency exit, type 1, and type 1. So 5 pairs of the door. Who could recall me what is the number of passengers or rating of the door for type 1?
110 maybe.
For type 1?
45.
45, thank you. For type A?
110.
Okay, thank you. So 110, 110, then 45 and 45 passengers. What about the locations of them? They are located on fuselage station 200. What does it mean 200? FS 200.
Нижняя балка пола.
It's a zone of the aircraft.
Fuselage station. It's
Ну, ой,
distance in inches from the reference point. In our case, it doesn't matter where the reference point. It will be a basic or baseline for our calculations. It will be 200 inches. Then next one is located on fuselage station 750. Next one, 1200. Then 1875. And 2200. So it will be zone A. It will be B, it will be C and D. 4 zones will be on the A plane. So first step. Так, а мы как-то можем тут писать текст. First one, it will be individual zone passenger capacity determination. I'll make just an abbreviation. Individual zone passenger capacity determination. For zone A, what is the individual zone passenger capacity for this zone? It will be sum of these boundaries. Zone A will be 155. For zone B, it will be 220. For zone C, it will be 110 plus 45, 155. And for zone D, it will be 90. Then, next step, we need to determine secondary zone passenger capacity from nose to tail and from tail to nose. So what does it mean? We make a combination of these different zones. So it was the first step. Next step, so next step, it's a secondary zone passenger capacity from nose to tail. First one is A plus B. It will be determined as next. 45 plus 110 plus 110. 265. Next one. A, B, and C.
А почему мы 2 раза 110 добавляем?
Because we talk about the combination of these two zones. First, type A, type 1 exit, then type A and type A. We have 3 pairs of exit in this combination of the two zones.
Я поняла, хорошо, спасибо.
Then next one, it will be A plus B plus C. 45 plus 110 plus 110 plus 45. It will be 310. Then сделал ошибку. Ладно. Then it will be an tail to nose check. We will use zone D plus zone C. It will be 45 plus 45 plus 110. And it will be 200 passengers. Then D plus C plus B without A. We don't need to take it in account. It will be 45 plus 110 plus 100. Sorry, I missed something. 45. It will be 355. Oh, sorry, 310. My mistake. And for maximum passenger seat configuration, it will be A plus B plus C plus D. It will be 355. So now we'll use a maximum passenger configuration and possible allowable limits for the combination of the zones from tail to nose and from nose to tail. It will be useful if you will make some different layouts for the A-plane, but in our case we just determine the maximum allowable limits. If you have already existing layout, for example, you have 30 passengers in business class in the in zone A, and then 50 passengers in zone B, and so on. You must check it by these combinations. But in our case, we just prove the maximum allowable limits. But if you have already existing configuration, you must compare your configuration with these results. The sum must be not more than these allowable limits. Okay, is it clear? То есть здесь мы суммируем по максимально возможным допустимым пропускным способностям двери. Но если у вас уже есть готовая конфигурация самолета, которую нужно проверить, то вы должны вашу конфигурацию сравнить вот с этими значениями допустимыми. Возможно, получится так, что при комбинации пассажиров, которые у вас есть компоновка, там, например, вот тут допустимое значение 200 у вас получается по расчетам, а у вас комбинация дает там 201 пассажир. Все, значит, вы допустили ошибку в планировании, разработке конфигурации вашего салона. Okay, next step. It's exit distribution with respect to the fuselage. So the length of the cabin. What is the length of the cabin? The initial point is 200 inches. The last one is 2200. The total length of the fuselage cabin is 2000 inches. It will be length of the cabin. Next, you need to determine the number of exit units in each zone. Exit units, as you remember, we need to divide rating of the door on 35. So for zone A, it will be 45 divided on 35 plus 110 divided on 35, and you need to round down to nearest quarter. It will be 1.25 plus 30. For zone B, it will be between A and A. Double type A from both sides, so it will be 6. 3 plus 3. It will be zone B. From zone C, it will be A and type I, type 1 door. It will be 3 plus 1.25. 4.25. And for zone D, it will be between type 1 and type 1. 1.25 plus 1.25. And the total number will be 2.5. So now we know a number of exit units for each zone. What is the total A-plane? As you remember, we need to summarize all of them. It will be 4.25 plus 6 plus 4.25 plus 2.5. It will be 17. The total exit unit for A-plane is 17. Next step, we will determine fuselage length factor. Fuselage length factor will be determined as the length of the passenger cabin. It will be a difference between this initial and aft point, so 2000 inches divided on 17, and it's approximately 117.6 inches. It's a fuselage length factor. What about the location of the exit doors? This door and these doors are boundaries of A-plane. It's the initial and last point for our calculation. So we could not shift them. We could not make a decision to change the location. So without any possible any possibility to move them. And for exit 1, we will use flight station fuselage station 200 as a rule. For exit 2, we need to check it by the calculations. So what was the type rating for exit 1?
Uh, 3.0.
No.
Які
One.
питання?
So do you remember? Unfortunately, I erased it. What is the total exit units for zone A? 4.25.
Угу.
Yes.
It's a type 1 plus type A exit. And it will be position of exit to door from the calculations. 200 inches, it's an initial door, type 1 position, plus 4.25 multiple on our fuselage length factor, 176 inches. And it will be, from my calculations, 699.8. It's the position of the door. For exit 3, it will be determined in next way. We will use position of this door in inches, 6998 plus type A, and type A give us 6, so 6 multiple on 16.6. It will be, from my calculations, 1004, 5 and 4 inches. For exit 4, it will be 100.5.4 plus 4.25, because we talk about A and I, multiple on fuselage length factor. It will be 1905.2 inches. And for exit number 5, the last one, we use the already existing number because it is a boundary. So it will be 2200 inches. Then you need to compare it with your variance. In this case, the exit door was on 750 inches. Your calculated value is 699, so it will be difference 50.2 inches. It's a shift of the door from the calculated value. Then for this one, it must be 120. In our case, it is difference approximately 205.4, not approximately, directly. And for exit 4, it will be 25.4 in comparison with this value. Then, as you remember, this difference must be less than 15%. So how we'll determine this difference? We must divide it, this value, on the length of the fuselage cabin. So we must divide it 50.2 on 2000 inches, and it will be 2.5% approximately. Here it will be approximately 10%, and here it will be less than 2%. So all exits are located in correct position. So here you could see an algorithm for the calculation of the right position of the exits, and you prove it that they're located in correct position. But if you have this difference more than 15%, maybe you will need to shift your door in your structure, in your design, or maybe you will reconfigure your A-plane. You have limitations in your A-plane. You could not use more than, for example, it was 110 passengers for type A, but in this case you will limit it by number of passengers, maybe 75 or other. It's up to the calculations. Okay, what about the questions? I give you example of these calculations in normal text form, and your task will be connected with the proving of the Sukhoi Superjet disaster, and there were a lot of notes in internet about that A-plane was designed with problems, because if you look on Embraer 110, so if in KLM example you could see that Embraer has an mid type 3 exit doors. If we talk about Sukhoi Superjet, it hasn't, but they look similar, and a lot of notes in Facebook and other social networks said that it was a mistake in the calculation, in designing. So your task for homework will be prove this, or agree with these notes, or said that A-plane was designed correctly. I give you an explanation of this note, of this homework in the task that will be in Google Class. Okay, so maybe some questions about our lesson.
All of us will have the Sukhoi Superjet.
Yes,
The same configuration.
yes,